Hi, hello everyone, greetings. Welcome to Module 3A, Building Transportation System, Part 1. My name is Architect Technologies Azrul Ismail. I'm going to be your lecturer for this module. Building Transportation System. The purpose of movement system in a building. Function to assist the end user movement inside the building. Categories can be divided into three. 1 lift, 2 escalator, and 3 travelators. There are many types of lift and escalators. They serve different purpose with the different needs. For example, to uplift heavy goods and material, we use a base lift. To reaching higher floors in a tower building, passenger lift. Reaching disabled person to upper floor, disabled lift. Firefighting and escape, we use fire lift. Speed up human traffic movement at airport terminal, we use travelator. Reaching immediate floor, we use escalator. Facade maintenance and work at height, we use gondola or skylift. How building transportation may affect the buildings. In terms of space, we should know how to locate the system as it would affect the space and the floor size. Structure. Consideration for the right structure to support the system. Design. Building can be built taller and deeper for basement. Let's start with lift. For UK, the name is lift, whereas in US, the name is elevator. Well, by definition, a lift is a type of vertical transportation equipment consisting of a compartment housed in a shaft that move people or goods between floors of a building, vessel, or other structure. Basically, there are two types of lift system technically. On the left side is cable traction lift, and the second one is hydraulic lift. We can see on the table what are the differences. Let's start with the number one. Cable lift powered by electric motors that drive traction cables and counterweight system, whereas hydraulic lift powered by electric motors that pump hydraulic fluid, normally oil, to raise a cylindrical piston in the application of Pascal principle. Cable lift serve low-rise, mid-rise, and high-rise buildings, whereby the hydraulic lift, they serve low-level buildings with 2 to 5 floors only. Cable lift cost is higher, 15 to 25% more expensive than the hydraulic system, where hydraulic lift is more affordable to install, less expensive to maintain and repair. Cables lift ride smoother and at higher speed compared with the hydraulic types. Hydraulic lifts operates at lower speed, typically 150 feet per minute or less. Cable lift is more energy efficient because it uses a counterweight to offset the weight of the car and occupants, where hydraulic lift takes a lot of energy to raise a lift car to several stories. How does it work? Let's start with hydraulic lift. First, an electrically powered pump that pushes pressurized hydraulic fluid, normally oil, to a jack lifting system. As you can see on the diagram, there's a yellow indicated circle showing the fluid tank controller together with the pumping equipment. So what it does is it pumps the oil into the piston. Second, the piston within a cylinder at the base of the elevator pushes the car up and down. So in this case, the car being pushed by a hydraulic mechanism. Thirdly, to go up, a pump pushes oil into the cylinder, pushing the piston, which push the lift car up. To go down, the valve opens and the oil is allowed to flow back into the reservoir and it pushed back using the gravitational force of the lift car. Well, how does the cable or traction lift works? Firstly, steel ropes are looped around sheaves connected to an electric motor. The sheaves have a counterweight attached at their end to balance the load of the elevator car. Traction on the rope raises and lowers the elevator. Within the cable lift type, there are two types of motor. The first one on the left is cable lift with machine room, meaning the motor will be installed on top of the lift shaft structure, which is detached from the lift car. Whereas the second type, machine roomless lift, means the motor will be attached together with the lift car. So in this case, the building don't need to have a machine room on top of the lift core. Referring to the most common lift, which is traction lift, here are the lift components, or we can say the anatomy of the lift. There are 11 main components. Firstly, machine room. Second, controller. Third, lift machine or the motor. Fourth, lift shaft. Fifth, lift pit. Six, the buffer. Seven, overspeed governor. Eight, guide rails. Nine, lift car. 10th, counterweight. And 11th, lift door. We will go through one by one on explaining how it works and what it is. Let's start with the first one, machine room. Machine room normally located above the shaft. Usually it will be at the roof level or rooftop level. This room allows for the technician to repair or make any maintenance works to the motor room. The size or the dimension of machine room pretty much depends on the orientation and numbers of the lift shaft in the building. However, the minimum dimension on the height is advisable to be minimum clear of 2600 mm. Second, the controller, or known as control panel. The control panel is installed normally at or inside the motor room. It's a system to control the lift, either manual or automatic. With the help of advanced microprocessor technology, lift control panel parts control the elevator operations. Typical control software of an elevator includes an operating system, task scheduling programs, input, output, and communication programs, programs of optimizing and controlling the operations of the elements. The third one is the machine or lift motor. A machine, either gearbox or wheel, driven by electric motor that controls mechanical movement of the lift car by rolling steel hoist ropes over a drive sheath. Located at the top of the lift shaft, for example, in the machine room or lift motor room. Next, let's have a look at the lift shaft. It's a vertical passageway in a building to permit the passage of a lift from floor to floor, constructed with reinforced concrete material. Accommodate the loading and fire resistance. Size of lift shaft space is determined by the lift type or specification, referring to manufacturer detail. It's also known as hoistway and lift well. Number 5, lift pit. At the bottom of lift shaft, there will be a place where we call lift pit. As the name suggests, it's located below the lowest landing level, containing the lift buffers. Well, what is the purpose? For slower lift, this is to house a spring type buffers, and for higher speed lift, this is to house oil loaded buffers. The size, depending on the lift specification, that can be ranges from 1.4 meter to 2.8 meter height. Next is the lift buffer. What is a lift buffer? It's a device designed to stop a descending lift car or counterweight beyond its normal limit. It prevents the lift car from hitting hard when the car or counterweight is slipping towards the bottom of the shaft. There are 3 types of buffer available based on the lift specification. The first one, it could be a polyurethane buffer. Second, steel spring buffer. And the third is oil damper buffer. So this buffer is mounted at the base of the lift pit, which is inside the lift shaft. Let's move on to the overspeed governor. This is a speed monitoring device that monitors the speed of the car and counterweight. It provides a signal to the control and activates the safety when lift is overspeed in either direction. Functions as the cable brake in case of emergency. Placed at the top of the lift shaft, for example, in the lift machine room. Next is the guide rails. It's the structure member fastened to the walls of a shaft, functioning as the vertical internal track. Fixed to side of the shaft, one guides the lift car and the other one for the counterweight. Operate as stabilization within the shaft during routine use and as a safety system in case of emergency stop. Next is the lift car. It's a compartment or room where passengers or goods are transported from floor to floor through the shaft. Constructed with a steel framework for durability and strength. Minimum width and depth of the car shall be 2000 mm and 1291 mm for wheelchair. As you can see, here are the external look of the lift car and also the internal look of the lift car. Next is the counterweight. Consists of individual flat plates of steel stacked together to counterbalances the load of the lift car. As the car rises, the counterweight descends, balancing the loads. The counterweight is calculated to match the weight of the car and half load of passengers. Alright, last but not least, number 11, the lift door. Minimum height of the entrance shall be no less than 2 meters. There are single side slide opening, which is one panel door opens either to the right or left. Usually opening width is between 600 to 900 mm, and this is common in older buildings. The second one is two panel center opening. Considered the most efficient door opening, passenger can pass through the entrance before the door are fully open. Standard opening around 1000 to 1500 mm. Two panel side opening. Opens in one direction. More space efficient but slower for passenger transfer, usually used in non-intensive application. 4-panel center opening. Opens in opposite directions. This arrangement is used on entrances of 1,400 mm wide and above. I think that will be all for this time around, and stay tuned for the next module. Thank you. Assalamualaikum.